In the previous video, we looked at how the Egyptians performed multiplication of two natural numbers. In this case, we'll look at how the Egyptians performed division of two natural numbers. And the first case that we're going to consider is the case where the divisor evenly divides the dividend. And the division was performed in a way that mechanically was almost identical to the way that multiplication was performed. The sense of what they did was this. They found a number that they could multiply the divisor by in order to get the dividend. So that number that they could multiply the divisor by to get the dividend was going to be the quotient. And the way they formed the quotient was adding successively smaller powers of 2 until they had something that they could multiply the divisor by in order to get the dividend exactly. Now, here are the details. Here's how they did it. They expressed the dividend as the product of the divisor times the sum of powers of 2. And how did they do that? Well, beginning with the divisor itself, the divisor was successively doubled until an amount larger than the dividend was obtained, each time denoting the corresponding cofactor or power of 2 of the divisor. Now, let's say this a different way. Beginning with the divisor itself, the divisor was multiplied by successively larger powers of 2 until an amount larger than the dividend was obtained, and each time they denote the corresponding power of 2 by which the divisor was multiplied. These multiples of the divisor were added together to obtain the dividend exactly. And the cofactors of the divisor were added to obtain the quotient. Okay, let's take a look and see exactly how this was done now in an example. 255, the dividend, divided by 15, the divisor. And what we're trying to do right now, I beg your pardon, what we're trying to do right now is express the dividend as the product of the divisor times the sum of powers of 2. So we'll begin with the divisor itself, 15, and we'll multiply it by the smallest whole number power of 2, that's 2 to the 0. Then we'll take 15 and multiply it by the next largest power of 2, 2 to the first. And our divisor 15 times that power of 2 is 30. Continuing, we'll take the next largest power of 2, 2 to the fourth, and multiply our divisor by 2 to the fourth, so that's 60. The next largest power of 2 is 2 to the 8th, 15 times, 2 to the third here, 8. 15 times 8 is 120. We'll take the next largest power of 2, 2 to the fourth, which is 16. And our divisor 15 times 16 is 240. If we take the next largest power of 2, 2 to the fifth, which is 32, and multiply it by 15, we get 480. That's way bigger than the dividend. So we stop. This is the divisor 15 times the largest power of 2, 16, that's less than or equal to the dividend. Now here's what we're going to do. We're going to add up these multiples of the divisor to get exactly the dividend. starting with the largest multiple, 240. Okay. Can I add 120 to our sum and get something less than or equal to the dividend? Nope. Can I add 60 to the sum, 240, and get something less than or equal to the dividend? 240 plus 60 is 300? Nope. That's larger than the dividend. Can I add 30 to my sum, 240, and get something smaller than the dividend? No. Okay. Can I add 15 to the sum, 240, and get something less than or equal to the dividend? Well, yes, I can. 240 plus 15 is 255 exactly. So here's what I've established. As far as multiples of 15 go, 240 plus 15 gives me my dividend, 255. And what I want to look at now are the corresponding powers of 2, 16 and 1, that I multiplied the divisor 15 by to get the dividend. 1 plus 16 is going to be my quotient. And notice what we've actually done here. We've taken our dividend and our divisor 15 and found those powers of 2 that I had to add together, so that my divisor 15 times the sum of powers of 2 would equal my dividend. That's the thought process behind this. Now let's move on to something a little bit more complicated. If it seems like maybe I rigged the numbers on that last exercise so that things came out nice and easy, I guess I have to admit that that's true. So what about when the divisor does not evenly divide the dividend? Okay, in the case where the divisor does not evenly divide the dividend, the division is performed by 1, multiplying the divisor by successively larger powers of 2. Well, same thing we were doing before. Stopping the process when a number larger than the dividend is obtained. Same thing we did before. And upon discovering that there is no sum of the divisor times powers of 2 that will give us exactly the dividend, we go to step 3. And step 3, we have an option here. We multiply the divisor by successively smaller powers of either 2, beginning with 2 to the negative 1, or we multiply the divisor by successively smaller powers of itself, beginning with the divisor raised to the power of negative 1. And I'm not really sure there's any well-defined criterion in choosing one option over the other. The next step, we add up exactly those multiples of the divisor that are required to yield the dividend and eliminate all others. Well, that's what we did before. And then finally we add up the multiples of 2 or the divisor that correspond to the multiples of the divisor that are required to yield the dividend. Well, I said a mouthful there. Let's do an example. 265 divided by 3. And the first thing that we're going to do is we're going to multiply the divisor 3 by successively larger powers of 2. Well, here's 2 to the 0. 3 times 2 to the 0 is 3. Here's 2 to the first. 3 times 2 to the first is 6. Here's 2 to the second. 3 times 2 to the second is 12. Here's 2 to the third. 3 times 2 to the third is 24. And let's see, how far am I going to go here? I think I'm safe. 2 to the fourth, 16, times my divisor 3 is 48. 2 to the fifth, 32, times my divisor is 96. 2 to the sixth, 64, times my divisor 3 is 192, I hope. And now 2 to the seventh, which is 128, times my divisor 3. 128 times 3, I don't know what it is, but it's certainly larger than my dividend, 265. So now I stop. And I do one of two things. I either multiply the divisor, which is 3, by successively small powers of 2, beginning with 2 to the negative 1, or I multiply my divisor by successively smaller powers of itself, beginning with the divisor raised to the negative 1 power. So here's 3 to the negative 1 power, 1/3. 3 times 1/3 is 1. Is that going to get me what I want? Let's see. Or do I need more? I form a sum starting with the largest power of 2 that's less to the dividend, so that's this guy. My sum so far is 192. Of those multiples of the divisor that are less than, well, those multiples of the divisor that are remaining, can I add 96 to the sum and get something less than or equal to the dividend? If I add 96, I'm going to get 188. Nope. 288 rather. No good. Okay. I'm going to cross that out. Can I add 48 to 192 and get something less than or equal to the dividend? Almost certainly. 192 plus 48 is 240. Yep. So I will add that. Now what about 24? Can I add 24 to my sum, which is now 240, and get something less than or equal to my dividend, 265? I can. If I add 24 to my sum, I have, let's see, 192 plus 48 is 240, plus 24 is 264. I am 1 less than my dividend. Now, can I add any of these numbers to my dividend and get something less? I'm sorry. Can I add any of these multiples of the divisor that are left to the sum and get something less than the dividend? My sum is currently 264. I can't add anything larger than 1 to the sum and get something less than or equal to the dividend. So this guy is out, this guy is out, this guy is out. But what about this guy right here? This is exactly what I need to add to my sum to get the dividend exactly. So I add the 1 to my sum, I get 265 exactly, which is my dividend. And now I look at the corresponding multiples of 2. 8, 16, 64, plus the divisor, the multiple of the divisor. And the sum of these things gives me my quotient. My quotient will be 64 plus 16 plus 8 plus 1/3. And I guess what is that? 88 plus 1/3. That's my quotient. Now let's look at another one. Another one where the process ends up in a slightly different manner. Uh, 221 divided by 8. My first step, multiply the divisor 8 by successively larger powers of 2. 2 to the first times 8 is 8. No, I'm sorry. 2 to the 0 times 8 is 8. 2 to the first is 2 times 8, which is 16. 2 to the second times my divisor is 32. 2 to the third times my divisor is 64. 2 to the fourth times my divisor is, 128? And 2 to the fifth, which is 32, times my divisor, that's going to be 256. That's bigger than the dividend, so I stop here. Now I take stock of what I've got. I'm going to try to get my dividend exactly by multiplying, by adding the multiples of my divisor, starting with the largest multiple. My sum is equal to 128 right now. Can I add 64 to it? I can. I'm going to get 192, I think. Yep. Can I add 32 to that? Let's see, that'll give me 194 plus 30. No. Now, can I add 16? Oh, let me cross this out, by the way. My sum right now is 192. Can I add 16 to that? Definitely. I'll get 208, I believe. Okay, what about 8? Can I add 8 to that? Yes, I can. And I guess I will have 216 if I'm not mistaken. But I don't get the dividend exactly. So here's what I'm going to do. I'm going to multiply the divisor by successively smaller powers of either 2, beginning with 2 to the negative 1, or by successively smaller powers of the divisor itself. Well, here's my divisor, or there's my divisor. Successively smaller powers of my divisor are going to get me eventually the smaller powers of 2. So I take my divisor and multiply it by successively smaller powers of 2, starting with 2 to the negative 1. 8 times 2 to the negative 1 is 4. Now let's see, what is my sum? 128 plus 64 is 192, 208, 216, 220, okay. All I need is 1. Take the next smallest multiple, 2 to the negative 2, so that's a quarter. My divisor times 2 to the negative 2 is 2. If I add 2 to my sum, I get 221. Nope, no good. I went over. Okay, let me cross this out. Let's take the next smallest power of 2, 2 to the negative 3, so that's 1 over 8. I take this power of 2, 1 over 8, times my divisor, 8. That gives me 1. And if I add that to my sum, I get 221. Bingo. So these multiples of the divisor, 128, 64, 16, 8, 4, 1, add up to the dividend. Now what I want to look at are the powers of 2 that I had to multiply the divisor by to get this. And I had 16 plus 8 plus 2 plus 1 plus 1/2 plus 1/8. And this is my quotient. And let's see, that's 16 plus 8 plus 2 is 26, 27 plus 1/2 plus 1/8. So 221 divided by 8, 27 plus 1/2. Whoops, let me raise this up, forgive me. My quotient is 16 plus 8 is 24, plus 2 is 26, plus 1 is 27, plus 1/2, plus 1/8. This is my quotient.